Folks, welcome to Mr. Circuit. I've taken apart a JP8000 Roland synthesizer and we're going to have a look on the control board. There's a common fault, capacitor 219, which is situated over here. It tends to cause a low output problem and some distortion. I haven't used it for a few months. I got it out and for some reason the output was quieter than usual and it was distorting quite badly. So basically we're just going to run some tests on it now and make sure it's the correct capacitor that we've got to change. So here's a quick look at the JP8000 in bits. It's not too bad to take apart, but if I was you, I'd just take some photographs while you're doing it, and also what I do, I number the ribbon cables, and that way when you come to put it back together you're not kind of lost when you're thinking where did this go when I took it apart. So quite important to do that. Okay, so let's have a quick look at the resistance reading we're getting on 219. Okay, we've got a number. It's bouncing about quite a bit, fair few mega ohms. Obviously, it's in circuit. Usually, we test capacitors out of circuit, but there are a few ways we can do it in circuit, and I'll show you right now. So here we're measuring the capacitance. It's supposed to be a 22 microfarad capacitor, and we're reading 22.85 around there. Basically with capacitors they have a tolerance of plus or minus 10%, so I mean, you know, 10% of 22, 2.2, so that's well within range, so it actually looks okay. However, let's try another test. Okay, so basically now we're going to test the ESR of the capacitor, which is the equivalent series resistance. Now this ESR meter, it's pretty cheap. I think I got it for about £6 off eBay. Testing it against a decent multimeter, it's not that accurate. However, it's good enough to kind of show you any problems that might be occurring. So if we look at the ESR reading we get on this capacitor, okay, basically the capacitance reading's a bit different. We get 19 microfarad. I know that's not very accurate. However, we're getting 10 ohms of resistance on the capacitor. Now, usually you'd expect that kind of reading on a big filter capacitor, but on a small capacitor like that, that's a very worrying reading. And just to kind of put you in the ballpark, I'll test the capacitor next to it. Look at the ESR reading there. Oops, get in there. Okay, just to show you the difference, you're at 0.3. I was jumping around a bit. These aren't the best test leads, really. But yeah, we're getting you know, a hell of a lot lower. So we can tell that capacitor's bad. That might be causing my problem. Certainly, it seems that other people who've encountered problems with the JP8000, they've had a lot of luck changing this capacitor. We can see it's bad, so let's swap them out. Now we need to look at which ones we're going to change out. Obviously, we've got a bad one there, and it's quite possible we've got other bad ones. So we'll start just going round. We'll take some ESR readings quickly. Okay, if it actually gives me a reading. Today will do. Better. Ooh, got 13 ohms there. That's not good on such a small capacitor. Let's see what we get here. .06, so we can see that's a hell of a lot better reading. I did hear a rumour a long time ago, especially with Sony gear, and this is sort of in the 90s. They used some kind of fish oil when they were manufacturing the capacitors, 1.2 on that one. And basically the story goes they were quite prone to leaking, and because basically there was some industrial espionage, a guy got hold of them, gave another company the recipe and the instructions to make them, and apparently they leaked. But of course they brought all these cheap capacitors onto the market, and a lot of consumer gear had these capacitors in, and it caused all kinds of problems, eating through the board when it was leaking, and all sorts. There you get 0.29, 0.3, it's moving about a bit. So the JP8000, it was out in about 1997, I think, and essentially it's just that, you know, that might well be those capacitors. 0.47, I'll change the test leads. Oh, 8.96 even. No, point. Okay, so, you know, we've got a couple of strange readings here. I'll test all these ones in a minute. But you get the idea. You need to get ESR readings off the capacitors, and if you're reading something which is way out of the kind of range you'd expect, I mean, there's sheets online which kind of give you the sort of ballpark readings with capacitors. I mean, I sort of know off the top of my head 10 ohms is quite high, but you know, for low ESR capacitors for audio circuits, you know, you should be sub 0.1 on smaller caps. So right, I'll just identify these and we'll focus on the soldering. Okay, so having measured all these capacitors, I've kind of marked them, the ones that are bad. Oh, let's get it in focus. Yeah, that one next to this one, and this one here, that one's also bad. That was the bad one before. But over here we've got all these capacitors marked with blue that have got the really high readings. In fact, there's more that are bad than are good. Now, I mean, quite often, you know, it's one of those. I mean, you know, these capacitors, they're from the 90s. There's a chance it might be those fish oil ones I was discussing before. I'm going to take the step here. I'm just going to replace all the capacitors on this board, and then that way I know for sure that I'm not going to encounter problems in a few years. They're all mostly got high ESR readings, so I don't have any confidence in them. So what we're going to do then, we're going to unsolder them and swap them over. Okay, so tin the iron. Just a rule of advice: don't do it above chips. Not a good idea. Okay, so we'll just heat up the trace here. Sorry, the pad. This solder pump's absolutely useless. Try this one. Heat on there. The tip's a bit thick on that, so get some desolder braid on the case. Cutters. Discard that. Actually, we can use that bit. I use braid to just try and pick the ends apart. That way it soaks up the solder a little bit better. Okay, it's not running too well, so a bit of flux in there. Okay, it should run all over the place now. It should soak up easier. Okay, we're getting there. Now we've got to try and get in that back bit there, not so easy. So again, what we do, pick apart the end, just open it up a bit, let the solder run through, bit of flux. Okay, this sort of flux I use is this Lithuanian stuff. It's pretty good stuff. Oops. Okay, we've got to watch out. There's a little capacitor there. There's tiny resistors here, so we've just got to make sure we get right on that copper pad there. Right, probably a bit easier if you see it like that. Okay, now I've got rid of the bulk of it. You can simply just get a pair of tweezers. Okay, it's starting to loosen there, starting to loosen there. Okay, getting a really strange smell from that. Probably melting plastic around the capacitor, or as other people have described, a bit of leakage. Okay, whatever you do, don't pull on the capacitor because you'll rip up the copper pad as well and you damage the board. And seeing as the electronics are so tiny, you'll have an absolute nightmare trying to sort that out. Okay, doesn't want to go. So, we do get some more flux on there. Runaway flux. Okay, flux just helps the solder run that bit better. Okay, it's hanging in there for dear life. So fiddly. We love it really. Okay, try one more time. He's been a real pig. Okay, there we go. Wow, what a nightmare that was. Okay, and basically, where are we? Okay, and we see the copper pads there are intact. Now, they're covered in flux, so basically what we've got to do next is let that harden up and scrape it off. And we've got to get rid of all the flux off the board, because if we leave it on there, it can corrode through the solder mask, and it can also eat away at the copper traces. So it's very important that we get rid of that. Right, so basically, I just have a couple of cheapo tools for doing this. Got like a chisel tip screwdriver, so all we need to do is just break apart where it's crystallized on the board. And then you can either get rid of it using a toothbrush, or you can get a vacuum cleaner on it or something like that. So you just got to get, just make sure you get it all off. Okay, it's probably best just get rid of a little bit at a time. Okay, you just got to be careful when you do this and make sure you're not hitting any other components or scratching through the solder mask. You just got to take your time and make sure you get it done. There's a bit of a cramped area here, and if you think this is bad, you should see inside iPhones. They're absolutely horrendous to work with. You need a microscope to even see any of the components in some of them. But that's the way it's all going. It's all going miniaturized. Okay, nearly there. Okay, still a bit on there, but I'll do for now. We'll wait till we get another component on. We'll just make sure we take care of the edges there. Right, so the next step, we're going to replace the capacitors. Take it out there. We're dealing with a through-hole component here. Obviously these are designed to go through holes in the circuit board and be soldered on the other side. And here we've got a surface mount board. As you can see, everything's soldered on the top. So what we're going to do, essentially, is solder that in place like that. Then we'll just have to lean it over a little bit. We've got enough space. There's a heat shield on top of here, but we've got these cables coming out. Hopefully that should, if it's bent over a bit, it should just become below that line, so we should be okay. Here we can have a bit more trouble. I mean, we've got a lot of components spaced together, and these capacitors are quite big. It'll just, yeah, I mean, we should be able to get around it, so that's fine. So, right, we do trim the component leads down. We're ready for soldering. Right, so basically, we'll just heat up the pad there. Put a bit of solder on to tin it. And we'll do the same with the other pad. Okay, so this method's just tack soldering. Luckily I checked the replacement before because I videoed it. What you want to do is just one capacitor at a time. If you take them all off, you'll lose the polarity and you'll have an absolute nightmare of a time. Trust me, it's happened to me before. Okay, so if we just get that up right. Okay, so we just got that soldered onto the pads. Alright, probably we'll put a little bit of flux on it and reflow it just to make it a bit more solid. But in essence, we just want to attach it to the board there. Okay. We'll just get the forceps. That's it. That's a lot better. That's nicely welded. Okay, we'll just do the other leg. Okay, it's nice and solid. Okay, apologies, just trying to sort this zoom out. That's better. You can see that's nicely attached. If we look around the edges of those pads, we can see a bit of flux. We've got to clean that off the board as well, so we'll do that now. Okay, you can just see it's crystallised there. We'll just make sure we get that up. Okay, again, as I said before, it's important you don't disturb any of the components. Just take your time and be careful. And then using the desolder pump, we'll just suck up these bits. And it's just a case of keep going at it until you get it. But if we were just replacing that one capacitor, that'd be job done. Obviously, you just got to repeat the process for all of these little parts. Like I say, with the readings I was getting, it's just worth swapping them out. At the end of the day, they're going to go soon. You know, those high ESR readings. Just a matter of fact, capacitors dry up over time and their equivalent series resistance increases. So, you know, once you start getting over a couple of ohms, it's probably worth changing them out. Okay, so there we go. We replaced all those capacitors. It's a little bit time consuming, but ultimately worth it. And the reason being, at least we know they're not going to fail anytime soon. Okay, so having done all of these, I came across a couple of techniques that might help you. Okay, so firstly you want to make sure you clean all the flux. I've got some of my fingers there. Make sure you clean all the flux off. I used acetone and cotton wool bud as well. I used this scratching tool. I just scraped it all off and mopped up the excess. As you can see, it's pretty clean in there. Alright, but when you're actually desoldering, I'll find one that's basically, you want to get the iron in on the side there, heat that with a bit of flux, do the same for that side, and then using a pair of tweezers. Okay, so while you're heating it with the iron, get a pair of tweezers and you can start moving it opposite to whichever pad you're doing. So for instance, if I'm heating the pad closest to me, I'll be putting some pressure on that way. Now the important thing to note is that you don't put too much pressure on. If you're just putting on it like that and you heat it and then you think, oh, it's coming, you pull it some more, you're just going to rip up the copper trace and you're going to damage the board. And as you can see, trying to redo a trace on here would be an absolute nightmare. In the one place I did lift the trace a little, but fortunately it didn't rip off or anything. So you know, even taking the most care, it's a very fiddly one to do. So if you've got no experience, I say I wouldn't recommend this as your first one. However, as long as you're not applying too much pressure, you can just twist like that. I mean, you're not pulling, you're just sort of gently doing it. It'll give by itself. You'll know when to do it. And yeah, just basically, if you reach an impasse and it doesn't seem to be moving, just put more flux on so it flows the solder, and do it again. As for soldering, I had the iron at 400 degrees. Some people prefer it cooler for desoldering. Personally, I'd rather get the heat in there quickly and to get the component off rather than you know, trying to do it on lower heat. So yeah, there's a couple of things there to consider. So that's the main board done, and there's about 13 capacitors, I think. So let's move on to the next stage. Alright, so basically this switch here, it's not working, so we're going to troubleshoot that now. Alright, so taking the switch out, and basically when we test it here, we should we've got open line. Basically when we press it, we should be getting something. Well, that was just my fingers bridging the contacts there. You can hear that clicking. It's, oops, not having it. Obviously, yeah, you got to watch out for your fingers, because when you do that, you're bridging the gap, and they'll conduct through your skin. So always make sure you're isolated from your skin when you're doing that. So simply, it's just a case of getting one of these buttons and replacing it, and then we'll put it back together and test it. Alright, so we're all fixed up, working lovely, absolutely cracking sound to it yet again. Replacing all the capacitors makes all the difference. I can't believe how punchy it sounds. My patch button's also working. That's great, really happy with that. Another successful fix. Just when I was putting it back together, because of the capacitors I put in, basically there's a panel about here with a RF shield on. I had to bend one of the legs out of the way to get the shield back on, but it's fine, hasn't affected the performance or anything. Other than that, yeah, another successful fix. So see you again next time.